body moves from point A to point B, and it covers a distance of 100 meter in a time duration 10 seconds. Now, if you calculate speed, you will simply do the ratio of distance traveled upon time taken. Okay, and you will see the distance traveled is 100 meter. So you will put here 100, and the time taken is 10 seconds. So here you will put 10. This will come out to be 10 meter per second. Now, the speed that you calculated like this over a whole period of time, over a complete distance traveled, this speed is called average speed. Now, if you are said to calculate instantaneous speed, then you have to mention at what point, at what instant you have to calculate it. Suppose during from point A to B, his journey, I say that at particular instant at P, you calculate the speed. What was the exact speed at the point P? Because this might not be sure that he was traveling with a constant speed of 10 meters per second from point A to B. This might be a case when he was traveling somewhere with the speed of 8 meters per second, somewhere with 15 meters per second, somewhere with 20 meters per second. So his average speed came up to be 10 meters per second. That doesn't mean that at every particular instant his speed was 10 meters per second. So you will so when you are said to calculate the instantaneous speed, you have to mention at what instant. So we say, for example, at point P. Then to calculate the instantaneous speed at point P, you have to take the derivative of distance with respect to time. And now, how ds by dt, derivative of s with respect to time, came to the instantaneous speed, how the formula came to be into the existence, we will discuss this in the next section. So to further explain the concept of average speed and average velocity, and how the formula for instantaneous velocity came out to be derivative of s with respect to t, we will consider a simple example of s is equal to t square. This is the relation between the distance and time, which is given as s is equal to t square, which is nothing but a parabolic equation. So if you plot its graph, this will come out to be like this. Okay, so what you do, you consider 2 points A and B close to each other, very close to each other. Okay, you've considered it, no problem. So when you see what is the distance between A and B, what was its length, so what you will do, you will correspond point A to the s axis. This will come out to be s1. At point B, you will correspond it to the s axis, and it will come out to be s2. Now, if you see the time axis, if you correspond the point A to the time axis, it will come out to be t1, and for B, it will come out to be t2. Okay. So what you see, that this is the distance s2 minus s1 is equal to, we say it as delta s, and this is the distance t2 minus t1. This is the difference, sorry, t2 minus t1 we call as delta t. Okay, so this figure looks similar to a right angle triangle. If you draw it beautifully, neatly, you will come to know that this is a right angle triangle. Suppose this is point C. So this come out to be again point C. Okay, and this side BC is delta s, and this side AC is delta t. Okay, so if you are said to calculate the average speed between point A and B, what do? You divide the total distance traveled by the total time taken. That is nothing but delta s upon delta t. Okay, so if you analyze delta s upon delta t in this right angle triangle, suppose this is angle theta, and if you calculate here from here tan theta, this will come out to be delta s upon delta t. So if you compare this equation and this equation, you can say average speed can also be written as tan of theta. Okay, so now if we say that we have to calculate instantaneous velocity at point A, so how you will calculate? What we will do, we will shift the point B towards A, means we are shrinking the delta t, we are shrinking delta t, and it approaches to 0. So here comes the concept of limit. In mathematics and calculus, you will study it later on in mathematics, but here for simplicity we use this concept of limit as limit delta t approaches to 0. Okay, so and no changing you have to do in the above equation, it will be same written as delta s upon delta t. Okay, and you similarly can write it down as is equal to tan theta. Now, what happens if you overlap the point B on point A? What will happen? You will get a very interesting equation, very interesting result, that point A and point B overlaps. Then you get a tangent at point A. Now, how the tangent at point A is calculated in mathematics? You have to slope, and tan theta is slope. Now, how the slope is calculated in mathematics? What you do is you find the derivative of the function s with respect to time. So from here the formula comes for the instantaneous velocity. This is theta. So tan theta will be equal to slope of the tangent, and slope of the tangent in calculus is given as ds by dt, derivative of s with respect to t. So in order to calculate the instantaneous velocity at any point, you have to differentiate. You have to differentiate the given curve. So these were the things what we was to discuss in the concept of average speed and average velocity. See you later.